Record, that means that as soon as you're done with this exam, or the electronic exam, you will have to take the actual, sorry, as soon as you're done taking the exam, you'll get a second shot of it at it in a group. Those groups can be, you can organize before the exam, you can also organize during the exam, right? If you don't have a group member in the exam, just find a stranger, friend, victim, just get somebody. The groups are size 3 or 4, unless there's not enough people to split up into sizes 3 or 4. So if there's a couple people, if there's like one person left over, we'll shunt you into a group of 3 or 4 people. And if there's, like a pair left over, we can either split you up and shunt you, or you can just simply do that together. The group exam, you will get, the way I'm going to try to organize this, okay, is that there will be a second instance of the exam under the modules, okay? That's just something to click on, just like the other one, except it will say group exam. You'll want to, and only one of you will click on that, okay? Only one person per group will do that. Again, I'll email out these instructions, and I'm going to be meeting with the TAs tonight to go over that. So only one copy of the group exam, because otherwise it's just, you're taking the exam again and there's just happens to be people to talk to. No, with one person basically doing all the typing or communication, that means that that you have to actually, discuss your answers and communicate. And I do intend for the second part to be a vigorous discussion. It's a learning opportunity, which is why I want you to, that's the entire point of this. It's a huge learning opportunity. You're never more motivated to learn than the day of the exam, because there might be something that you missed. And for those of you who already know it, well, mastery comes through teaching. So, all right. So again, the exam is going to be much shorter. It's about 7 questions long. Okay, the actual exam is about 7 questions long, one of which you already know of, which is the compare and contrast array list to linked list. I will be going over that today. So again, it is open. It is pretty much open everything. I sent out the email previously with regards to what that meant, saying that basically you can use your IDE, you can use what's on Canvas, right? So you can use what's on Canvas, you can use what's on your you can use any paper that you bring with you. You can bring the textbook with you. You can have documents saved on your computer. You can use what's stored on your OneDrive. I have a very long bullet point list, which just basically is a very specific way of me saying no Googling for your answers, no going on Stack Overflow, right? You're even allowed to use you are even allowed to use things that are linked from Canvas, such as my lecture videos. That, and if you do need to review those lecture videos, right, remember to bring in some headphones for that so you don't disturb others. Okay, make sense? Yeah, just common sense there. Otherwise, YouTube subtitles do a pretty good job, and a lot of what you'd be going for is the code anyway. All right, so let's take a look at the practice exam for this course. All right. That's what we're going to be doing today. So if you need the time to work on stuff, sorry, that's just, I think you're just going to have more valuable time today. Yes. You will not have to code a circular linked list. You don't have to code a circular linked list. There might be a question that involves stuff, or that might involve you having to draw something that's circular, but there's not going to be anything that's required to code. I also do a singly linked list. Sorry, the nodes are going to be singly linked in any of the code you write, because again, time constraints. If I'm making that, I'd have to make you write and think through twice as many connections if it was a doubly linked list. So there's a reason for that. Okay. Yeah, most important advice, don't panic. Panicking during the exam is bad. Yes. Nope. Yes, that is my standard disclaimer for questions. So there are, if you have if you do come into an exam, there will be questions like in other things that are like, hey, select an option. Like on the second exam and the third and the final exam will have those kind of things. So those, if you have a justification for your answer, there's always places to provide those. Okay. All right. So short answer, we've got this doubly linked list over here, A, B, C, and D. So we basically want to follow the links. We want to figure out which node is being referenced by this chain. So we've got D dot previous, right? D dot previous, dot next. Sorry, D dot previous, and then dot next dot previous, right? So anytime we kind of see these change and we can, obviously if there's a previous and a next, they cancel each other out. The only thing you'd have to be careful for is that if there's a trick question in there saying, hey, you're going to go out of bounds. But this again is just to get more you thinking rather than to trick you. Okay. This is something that's less likely to be on the exam. It's more likely that the next questions come on the exam, but these questions came from a Harvard practice exam for their final exam. So I'm fairly good about, fairly comfortable in their, at least appropriateness. So let's see. Okay. Yeah. You gotta close that Discord window. It's blocking everything. All right. So now C dot next dot previous. All right, that's also B. Yes.
So if like C dot next, is it evaluate B and then we do B dot previous evaluate C?
Yes. Yes, because we need to otherwise you're gonna have trouble if it doesn't, evaluate like this, right? That's what you're asking? Yeah, it evaluates like that. That's a very good question to know, which is that basically that when you're using dots, it's going, outward like that. All right. Again, this one is just me being a jerk. This last one, which is dot next, prev. So B dot next, prev, dot next, prev. And if we actually just, again, do what I was mentioning, which is that we see two nexts, we see two prevs, we can cancel them out. And we see a next and a prev, we can cancel those out. And next and a prev, we can cancel those out, right? So, and the answer is B. So all these answers are B because that, just be aware that I am the type of professor who will do that because it's easy to grade. It's the same reason your math instructors so often have questions that are 1 to 5 answers: 0, negative or positive 1, and negative a half and positive 1/2. That's why you get those answers so often in physics and in mathematics when you're evaluating something, because it's easy for us to grade. And we can do convoluted things to get an answer of 1. All right. So write a sequence of commands that will remove the tail of a doubly linked list. So to remove the tail of a doubly linked list, right? And I'll do this one and the next one simultaneously because that helps. Using a linked list with 3 nodes, draw what happens to the list as we execute it. So head, tail, right? What we need to do is that we need to make this node be the tail. So the way we do that is we would say tail, and you'll just have to excuse my terrible, terrible handwriting. Tail, it's also, not the most stable surface to be writing on. Tail is equal to the thing that was before the tail. So tail is equal to tail.prev. And what you would want to do is basically as each line executes. So each change I'm making to this, right, would be like a separate drawing. But on the exam, I'll be interested in what happens at the end. I'll give you a line of the equivalent for this code on the exam is I will give you a smattering of code, okay? And then I'll ask you to draw what happens at the end. And you can feel free to draw, your intermediate steps so that if you make a mistake, you'll get partial credit, Yes.
We have access to the get node function for
Yes.
a single linked list.
Yeah. totally. Tail. Okay, so let's see. Now that that's the tail, we need to remove this node over here. So the way we do that is I'm going to say tail dot next dot previous is equal to null. And what that's going to do is I'm going to remove this. Since this is now the tail, dot next dot previous is equal to null, that's going to make this point, the previous point to, you know, nothingness. And then the final thing to remove it is, and again, apologies for my handwriting, I will be switching over to, when we're actually doing the coding problems, I will be switching over to Intellij. Tail dot next is equal to null. Okay, and that removes this, which will enable this code to get garbage collected, which I always imagine is like Pac-Man or something. Okay. So again, the way the garbage collector works is that Java keeps track of actually everything, that every memory location that you're using. And when it detects that the garbage collector is the thing looking for the garbage collector is the only thing pointing at it, it goes ahead and frees it for you. This is similar to in essence, what you kind of still have to malloc your code. If you're familiar with C, you're still kind of mallocing your data, your memory using the new command, but it handles all that messy kind of calculation for you. And then it handles the free automatically for you when it's not being used anymore. So much less likely to run out of space or to get out of that. All right, write a second sequence of commands that adds a new item to index 0 of a doubly linked list. That's just simply a long-winded way of saying add a new head to a doubly linked list. Again, we will do this here. And head, tail. Okay. So what we need to do is that we want to create a new node, new item to index 0. Well, we can, when I give you something a bit more ambiguous like this, feel free to write your assumptions, such as, you know, or just go for it. Depending, like here, I'm just going to say, okay, node E, and I'll just call it adding, right? Because it needs to go in. And the variable that is equal to new node, right? Item. We're going to assume that adding the new item, it's called item, right? And now what I need to do is that I'll create this new node, which is called adding. Okay. Now I need to say, now I need to connect it. Adding dot next is equal to head. Head dot previous is equal to not tail, but sorry, adding. Kind of on autopilot. And sorry for forgetting these semicolons here. I you know, I have to switch between Python and Java like every day, so it does kind of get a bit. So head.previous is equal to adding, and now since it's the front, this new adding node needs to be the new head. So we say head, the memory location for head is going to store this. So head is equal to whatever's stored in adding. Remember, whenever you're confused which direction it should go, the memory location on the right gets stored in the variable on the left. Yes. No, I'm just asking you for the code for this one. But again, on the actual exam, I'm going to be giving you code and you're going to draw it. Okay. Now the way you can draw it is, again, lots of, you know, you can either like draw it on the, you know, using like MS Paint or something, okay, and upload that. You can hand in you can get some scrap paper and hand it into the TA, okay, it's another way to do that. You can draw it on paper, snap a pic, tell the TA you're gonna use your phone to take a picture, take your phone to use a picture, and that, and email to yourself and all that. But again, the easiest way is just simply to draw it and probably hand it to your TA.
So how should I get you to just be?
Yes. You'd be getting 6 but you'd be getting 6 without the prompt and asking to draw 7, although it's a bit more convoluted. Yes. Are these what? My answers? I think I have something partially, I have a partial solution set for this, but I'm also going to post this video as soon as I'm done with class. Yes.
You don't have access to the file section. Yeah,
They removed it? Oh, yes, because things got mucked up by the, it's a long story with the research. So, all right, so let's go ahead, move files over here. Boom, right under assignments, okay? But again, to find the videos, just go to home, go to lecture recording. You can find that over here to get our lecture recordings. All right. And then this is a playlist of our lecture recordings, and then all the videos, top left button, sorry, the top right button, as it says over there. You can also get, if you're unable to see that, it's also linked right over here. Down here in the important links. They try to put everything that you need on that front page. Okay. All right, so now let's go ahead and open Intellij. Okay, suppose you have some list of integers. Yes.
No, like questions about it. Imports where you want to like the minimum max function. Do you need to say like import max?
If you need to. I mean, honestly, I'm not going to care. It's fine. You don't really need to. You don't need to declare your imports if it's in the Java standard library. Okay. Because, I mean, you can comment it in, but again, you're not really going to need it. Let me go ahead and create a new project. Next, final exam F 2022. Okay, this window. New Java class, list questions. So I'm just going to, again, just create this right over here so I can do it quickly. Okay. Let's see. And then how do I do that? Okay, reformat code, control, there we go. Control Alt L. Okay, so now for this one, again, write a method that finds the minimum and maximum values stored in the list and returns their sum. Part of the way I post these questions, by the way, is that it's part of my habit of I hate having code that doesn't return, I hate giving out code that doesn't compile, because then students complain that my code doesn't work, and then also my browser complains it doesn't work. Everything complains it doesn't work. It's very, annoying. So over here, it's gonna ask me to import list, whatever. I do so, right? It's one of those easy things to fix. All right, is the text big enough in the back, by the way? Great, okay. So min, max, right? And the reason we use min and max, you could do list.get0, but I didn't want to just give you list.get0 and remind you that get0 existed. Yes. Little bigger. Okay. Okay, settings, right. Okay, sorry. Editor. Font. No, the one you saw earlier was the UI. Was like how big should the UI font be? Okay, bam. Okay, that should be much better. Okay, so here min is the biggest possible integer value, since pretty much anything will be smaller than that. Similarly, the max value is the smallest possible integer value, because anything is going to be smaller than anything is going to be bigger than -2 to the 31st power. Right, that's why I said it that way. Okay, So now we just have to iterate through this. We only need one loop as opposed to two, or as you mentioned, you could do min and max with the functions, but here I'm just going to do for integer, for int num in list. I don't know why it likes to split it up like that. For every number in the list, we can ask it if it's bigger than if it's smaller than the min, if num is smaller than min. If num is smaller than min is the new number, right? This is just standard stuff you've done, hopefully a bunch of times by now. And then if number is greater than max, the max is that number. Right? And that is it. That's all you need to do for that one. Yes.
Like know how to use for loops? I never really.
No, you don't need to. Sorry, will need to know them when we get to sets, because there's no way to iterate over them over sets and maps other than using those, because they don't have indexes. But other than that, I mean, you can get away with just using for loop. Although, again, you should know that though, going over using a for each loop on a linked list will be more efficient than doing a for a regular for loop on a linked list, because you'll have to manually, for every item, count to where you need to go in the for loop, unless you manually control it. So it just depends. So here's the range of the big O question I will be asking you, which is what's the time complexity of this algorithm? This is one of those seven. Question over here is one of the 7 questions you'll be asked. What's the time complexity of the algorithm you just wrote? Okay. And the answer for this one, since I am going through this list and touching each of these one at a time, right? I'm going through each item, I'm touching it, looking at it, examining it, each of the n items once, then it's O of n. Yes. If number is less than the minimum number, yeah. Yes, because anything in the list will be smaller than the max value. Make sense? Yeah. So anything you find will be the new minimum value. All right. Now the big O. So the big O for this is going to be O of n. However, if I were to switch this up, and this is why I bothered putting this in the exam in the first place. If I were to do for int I is equal to 0, I is less than list.size, and then I++, your standard, your standard regular for loop that you've been using since forever. And then we say int I is equal to get, int I is equal to list.get 0. Not 0, I. Words are hard today. Okay, there we go. If I change the code to this, what's the runtime now? Still O of n or O of n squared? It depends. It depends, because in a linked list, right? This doesn't specify what kind of list we're getting. In a linked list, this get function runs O of n time. In an array list, this is constant time. And that's why we like to use the for each for that purpose. So just keep in mind, although, if you go through and write it like this and then bother explaining that might be worth an extra credit point. Yes.
This question is on the exam. If you put O of n, so that's wrong.
You would I think you would lose, I think you'd get a B on that question as opposed to getting an A on that question. I try to do each question when I try to go for partial credit, I try to like, is this an A answer, a B answer, you know, is this a half credit, you know, I try to do that. So it'd be, yeah, you've got it most of the way there. Yes.
Oh, wait, never mind. It's like, if you're with a linked list, then you can get I, it was a random number value of the,
Mhm.
oh, yeah, right.
Yes. So let's go ahead and now look at the next one, which is this one. And I got some interesting questions about this one. Okay. Which is that, like, so here, what is N in this case? Like N can either be each individual string, right? But strings can be varied length. I got asked this, and that was a very good question, right? So you can either consider, you know, all strings to be of the same average length, because if you have a number of strings, there will be an average length there, right? Or you can consider N to be the number of characters. Looking at it either way will give you the same answer for the O of N. Sorry, for this algorithm. So what we're going to do over here is that, suppose we have a list of strings, write a method called reverse words that returns a new list with all the strings reversed. I put in a comment over here what I wanted, because it is totally possible that if I did not put in this comment, you could misinterpret that as you wanted, you know, instead of it to being hello world nice, you might want that I want nice world hello instead of the words reversed. Make sense what I mean? If you see ambiguity by that like that, and that occurs, my general response is, well, and I won't be a jerk. I try not to be a jerk about these kind of things, right? I really try not to be a jerk about these things. The worst I will do is that I might say, I'm going to give you partial credit for this, come back some other time, you know, during office hours, and I'll ask you a different question, right? That is the worst I will do to you. You will never just simply straight out get something wrong with no appeal because of ambiguity. Most of the time, I'll just probably give you the credit though, because I'm a busy man with busy things to do. And all right, so suppose you have a list of strings, write a method called reverse words. So we're going to go ahead and take this, and I'm going to go ahead and copy this in here. And again, I will just go ahead and like post this in Discord when we're done, you know, so that it'll be easy to get like immediately. Okay, so public string, and honestly, these should be static methods. They should be static methods. So public static list string, reverse words, given a list, reverse everything in that. We are going to be returning an, sorry, did it say, and what did it say? Did it say a new string with all the lists reversed? So basically, I will have a new list string. List is equal to a new, and then you have to choose array list or linked list. Guess what? It doesn't matter in this case, because adding to the end of either is super easy. It's constant time for either of them. Okay, I'm sorry, and I'm not going to, I can't call it list because I've already used that, so I'm going to call it answer. And then I'm going to remember to return it so that I can get rid of that error, return answer. That's how I like to program. Like whenever I create my thing that I'm going to be returning, I remember to return it so I don't forget to return it. Very embarrassing on an exam to do that, but all right. So now for each string text in our list. Again, I love for each loops. This is also because I've spent so much time in Python, which is the only type of loop they have. For every text in the list, what we're going to do is that we have to reverse the list. Now, there's a couple ways we can go about, sorry, we have to reverse the text. Now, there's a couple of ways we can go about that. String reversed is equal to, we can do an accumulator pattern. Basically say, hey, for every single letter in the text, what we're going to do. So for now you could do get char, you can do your standard list and like do get character. So for I is equal to 0, I is less than text dot length, right? And then what we could do is we could say reversed is equal to reversed. Notice I didn't do plus equal. I did reversed is equal to text dot get character or get text dot get oh no, text dot car at bleh. And what that does is that adds, it takes each letter and adds it to the front of your answer. Okay. And the reason why that works is because like you'll do H and then you'll do EH and then you'll do LEH and then you'll do LLEH and then you'll do OLLEH. Okay. Another thing you could do is that you could totally, go through that in reverse, right? Or you could take advantage of the fact that there's other things in Java that exist in the standard library, and I'm totally cool with you using something if it exists, such as using new string builder. So string builder is something that takes in and what we'll do is that we will append. So actually, what we'll do is we'll do append the text to it, and then it has a reversed function built into it, and then toString to turn the what's inside of it into a string. What? Very much more efficient than concatenation. And actually, string builder has been made obsolete by a new string builder kind of thingy. I can't remember what it is. Expand method call into call chain sequence. There we go. String builder is equal to new string builder. We add the text to it. We then reverse the text. And then we turn it into that thing. But regardless, what we do need to remember to do is answer, regardless of how we do it, there's a million, again, I like questions where there's these list questions, I like making them open-ended and a lot of ways to do it. List.add the reversed to our answer, right? Gotta just remember to add that to our answer, right? If you forget to do that, again, I'm not going to be a jerk about it. I'm going to assume that you're moving quickly through an exam, right? And you'll maybe lose a point or two at like 10, It's not going to, probably a point. It's not going to, depends on how big of a deal it is, right? If you're doing the vast majority of what I've asked you to is iterating through a list. I mean, you created this thing, you probably meant to use it, you're returning it, you're probably meant to add it, right? If you forgot to, create it and return it, then you'll probably get a few more points taken off than just one, right? But not that many. Again, I try to be fair about these things. Okay, runtime for that. Every character gets examined once. So it's O of n, where n is the number of characters, and every string, every string gets examined once. So it would be O of n for each string. Each string would maybe run a bit differently because all strings have different lengths, but on average, they'd have a certain average constant length. Okay. All right. So over here, we'll do a linked list. So here, yes. O of n. O of n. So here, what we're going to do is that we are going to do a new project. Let's go ahead. So they have this, I have this linked list thing over here. I don't want to have to write, I just care about the answer on the exam, but you probably might care about testing it. I don't want to write another linked list though. Good thing I don't have to. I've already done that. So here I'm going to go to my GitHub repository. I'm going to go over here to destruct, which is for data structures. I'm going to go over here to linked list, and I'm going to grab my linked list class, which are perfectly available. Like, again, being prepared makes things easier. So over here is the code that I've done, and I'm going to go and let's see, what did I call it? So yeah, you're probably going to go and do the same thing and recheck and like, what did I call this? I did call it linked list. So let's go ahead and new Java class, going to call it my linked list because I don't want it to, possibly interfere with anything else I'm doing. Paste it in, gonna get an error, a single error saying, hey, this needs to match the actual, this needs to match the name. So I'm gonna change it to my linked list. And then one more, and then there's gonna be just a couple things over here and those things on the bottom, they're not that much of a big deal because guess what? They're just me saying linked list. So my, and then my. Okay. Again, though, this is unnecessary. I just care about the answer, but if you want something quickly, again, have it ready for you. And if you don't want to bother having your own, again, the GitHub is always available. Okay, so I'm going to go ahead and create so this one says, hey, write a method that deletes everything, right? Which removes all the items in the list, making it empty. So, okay, so public void delete list. I believe that so it doesn't take in any variables. I believe that that linked lists and array lists do have a function that does this. I believe it's called clear. Of course, again, so many languages, too many languages, but I believe there's something called clear that does it. So, but here what we do to do this is that first I'm going to do the thing that I don't want to forget to do. The easiest thing to forget. When I'm done with this, I need to say size is equal to 0, right? Set the size of the list equal to 0. Because when we empty it out, it's got to be empty. So there's a couple ways to do this. If I've got a built linked list like this, and again, is if, you're allowed to use the things we wrote in class. Okay. While, so I could do something like while size is greater than 0. This is probably the easiest way to do it. While size is greater than 0, list dot remove, or sorry, not list, but this dot remove, the first thing in the list, and we'll just do that. And we can just keep constantly removing the item in the list. But what if what if I told you you couldn't do that? What if you had to do it with pointers, right? Again, this was only a 3-point question, so I don't care. Something like this is perfectly fine. But what if you had to do it only with pointers, right? Again, practice makes perfect. Speaking of practice makes perfect, when you start going for your thinking, since the career fair is today, I think I might want to mention one of my favorite websites for tomorrow, blah, coming up. What I want to mention today is this website for handling for doing prep for interviews, technical interviews. It's called Pramp. It's short for practice makes perfect. It should be free. It shouldn't not be free. But basically what you do is it matches you up with other people who want to practice for interviews at the same time. They provide the questions and the answers. You spend 30 minutes interviewing them. They spend 30 minutes interviewing you. It's a great way to get all that nervousness of it being like the first time trying something new out of the way, because it's just a really good source. I've went through it. I can personally attest it's great. And the questions they give are good. I'll go into more detail in it later semester when there's more questions that are relevant from it. Right now, I just figured I should mention that. Okay, going back to doing this, right? If we wanted to go through with the with this, we could basically say head is equal to head dot. Sorry, we could do something like we could do something like this. One second. While there's a lot of ways to do this. So if you did away and it works, it's fine. While head is not equal to the tail. Oh, we didn't have a tail. So in that case, while head dot next is not equal to null. In this one, I didn't have a tail, whatever. So while head dot next is not equal to null. In other words, while we're not at the end of the list, head is equal to head dot next. So as long as I'm not advancing this to null, I advance it to null. In fact, I could do while head is not equal to null. Head is not equal to null. Head is equal to head dot next. While the head isn't equal to null, remove it. And then at the end, remember to set your size equal to 0. That's it. Yes.
You could say like head is equal to null, head dot next is null.
I suppose you could.
taking the 2 pointers.
Yep. You could just remove the head, assuming there's no tail. So.
Well, yeah.
Mhm. Again, there's lots of ways to do this. So I'm going to move on to the more interesting ones. Write an instance method called count. I'm trying to go fast here because I don't know how much time I forget how much time the more intensive and more important ones take. So write an instance method called count. It iterates over a linked list, returns the number of times an item occurs in the list. So again, it's an instance method, so it's going to exist inside of our linked list class. Okay. So this counts the number of times that item occurs in the list. So I'm going to create an int occurs is equal to 0. And I'm going to return that because we've got our answer, and then we've got our thing where we return the answer. And then what we've got to do is that we've got to iterate through this list manually. So the way we iterate through a list manually is that we create a node called current, kind of representing where our finger, if we're moving along the list using our finger, that's where our finger is. Node E is equal to, node E current is equal to head. Okay. Then what we're going to do is we're going to say, we basically have a loop again. It's going to be an indeterminate loop because we don't want to try to count manually. It's much easier to do these as indeterminate loops. So while current is not equal to null, because we're just going to keep going to the end of the, so there's always going to be two conditions for these. One of two conditions. You got to basically decide whether you want, while current is equal to null means you go through everything in the list, including the end. While current.next is not equal to null, means that you want to stop right before you get to the end. What you want to use depends on whether you care about having to address the tail or not, or whether or not you have to address, when you're looking at an item, you have to work with the item after it, right? So if you don't have to check the next item, current not equal to null, that's fine. If you have to check the next item, current.next not equal to null. Yes?
Can you use a for each loop here, or does that not work on linked list?
You'd need an iterator. So if you could, so if you're using the built-in linked list, you could totally do that, right? There's nothing stopping you from creating a my linked list class and saying extends linked list, right? There's nothing stopping you from doing that. So you have your own linked list class that you can add these new functions to. Does that make sense? In fact, that's probably a better way to do it, but as we'll see, it doesn't necessarily work for all the questions I have. Yes.
But usually, do you have access to the size of the link? From what I've known,
Yes. Yep. But doing it this way is good practice for the future questions. I'm trying to repetition breeds mastery. Okay. So while current is not equal to null, we say current. Basically, we just check the current item. If current dot item dot equals, remember doing the dot equals check uses the functions built in. The dot equals function built in to check the items. Double equals checks for the memory location. So if current dot item is equal to the item, then great. Occurrences plus. And then we need to advance it. And the way we advance it is we say current is equal to the thing after current. The memory location of the next node gets stored in current, which is what we're using to keep track of where we are. Okay. And that's it. That's all we have to do. For the record, that takes O of n time because, again, we're iterating through this and we're checking it each one time. If we use the get node function, iterated through and use the get node, that would take O of n squared because the get node runs in O of n time. And that's fine. It just, again, your code, what you put down for what what is the runtime of this code? It just has to apply to your code as opposed to anybody else's. Yes.
Just ask it what do while current dot item is not equal null, but you don't have to.
Nope, because you'd be checking if it's equal to null, which again, if that crashes, that's its own problem, in my opinion. Okay. Now, right, stack method. So we have 45. So we have about 35 minutes left. So that should be fine for this one. So this is part of merge. So this is part of merge sort. This is a static method. I'm still going to include it in our class. The only reason I didn't do linked list A over here and linked list B over here is because it wouldn't fit on one line otherwise. Okay. So let's just assume that these two lists over here, list A and list B, they are both linked lists for the sake of argument. Okay. Otherwise, the runtime for this is going to get messy. But again, it was one of those things where I had to make a choice between accuracy and readability. So I'm going to call, and then I'm going to call it my linked list over here. Doesn't matter. Again, for the purposes of this. And again, the thing about doing these exams electronically is that when you do it like this, when you do it in IDE, we get all these errors and we go, I've got to fix these errors, otherwise I'm going to fail the exam. As opposed to if you were doing it on paper and writing it down, you'd probably not even notice a minor error like missing a semicolon. And chances are I wouldn't notice that either, you know. So just account for the fact that basically that, yeah, you're going to have some errors. But if it starts eating up your time, don't dwell too much on it. Right? Go through, just in that case, just simply jettison what you're doing, open up Notepad, copy over what you have, and just type it out. Okay? Because otherwise, because you're going to let perfect be the enemy of getting a good grade. Okay. So what we're going to do here is that we've got two linked lists over here, list A and list B, and we want them to merge into one linked list. We want to merge them into one sorted linked list. Okay. So we assume that list A and list B are both sorted. That's part of the question, right? Takes in two sorted linked lists and merges them into one sorted linked list and returns it. Okay. So what we need to do here is basically my linked list of integer out is equal to new my linked list. And then we're going to return out over here. Boom. Okay. Makes sense. All right, so we have two sorted linked lists over here. Okay, let's go ahead and write a couple over here. Annotate 278. Sorry, I'll do 1 2 7 8 9. Sorry, 1 2 7 8, and I'll do 3 4 9. And yeah, 3 4 5 9. All right, and obviously the answer here would be 2 1 2 3 4 5 7 8 9 because I didn't put in 6. Okay, so how do we basically take these two linked lists and merge them together? Well, the idea here is that it's not actually that hard to merge two things that are sorted together. What we do is that we look at these, to merge two things like this into one sorted thing, we look at the first item. And we ask ourselves, which one's the smaller one? Which one goes first? Well, 1 goes first, okay? We remove 1 and we put it in our output. And then we just keep going, okay? We just keep going. Which is bigger? Sorry, which is smaller, 2 or 3? 2 is. That goes in our output, we remove it. Which is smaller, 3 or 7? 3 is smaller. Which is smaller, 4 or 7? Which is smaller, 5 or 7? Which is smaller, 7 or 9? Which is smaller, 8 or 9? And then we've just got our last function. We've got our last thing here, which is our end condition, which is, so we'll do this loop until we get to, until one of these things is empty. After that, it's actually fairly straightforward if you're using a regular linked list, because you have the add all method you can just simply call. Otherwise, you just simply try to add everything. You just simply add. If you've got other stuff like 9, 10, 11, you just simply go through and individually add all those to the end of the list, because they're bigger than everything that's already been stored. And they're already in the right order for you. So let's now see that in practice. Right, this is half of the algorithm for merge sort over here. It's especially efficient with if it's written to happen with linked lists. So what we'll do is while list A dot size is greater than 0, and we're about to type and again, there we go, two languages conflicting with each other, and size B is greater than 0. So as long as one of them doesn't have, as long as they're both not empty, right? It's both, as long as they both have stuff in it. And as soon as one of them doesn't have anything in it, we're going to stop and we're going to have to figure out how to go from there. What we'll do over here is simply say, hey, if list A dot get 0 is, and they're integers, so we know we can simply do this. If list A dot get 0 is less than list B get 0, then what we'll do is we'll say out dot add list A dot remove. Make sense? And again, if you're furiously copying this down, I am going to put this on Discord as soon as it's empty. Sorry, as soon as we're done here. So list A. So if this list A is smaller, we add it. We remove list A. Sorry, we remove the front item of list A. Otherwise, if the front item of list B is smaller, we'll remove that instead. What if they're equal? Does their code handle that if they're equal? Yes, it does. If they're, because the if statement asks if list A is smaller than list B, remove list A. So this else is not just greater, it's greater than and equal to. If you wanted a list A to be removing if it was equal to something, you do that. And then if you just didn't want any duplicates, you could make a third else condition if they were equal and, you know, remove one of them there without storing it. Okay, now that, and that's loop for basically, we'll empty one of them out. It's surprisingly short. Now that we are done, right? If we are working with our full linked list code, right? You could totally put something like this. Out dot add all, which exists for your standard linked list. It's going to error here, ignore the erroring, okay? But in a real linked list, this would work. Where you just simply say, hey, add all list A, add everything from list A, and then add everything from list B. Now, that might seem counterintuitive since we just added and removed a bunch of items from list A and list B, but we've removed them. One of either list A or list B, one of them has to be empty at this point. So one of those actions is literally going to do nothing. And the other one is going to add all the unadded items to the end of the list. Make sense? If we need to do that manually, instead, we just simply do a while loop. Right? We just simply say while list A is greater than dot size is greater than 0. And then we would do, and then we just simply take this this item over here, move it down here, and then we just simply copy this and change it to B. While there's still items in list B, remove those items from list B and add them to our output. Make sense? when you're moving your things around with linked list, you can do a lot of add or remove from the top, and it's very efficient. This entire operation, by the way, because we're always working with the front of a linked list, and any operation on the front of a linked list, get, set, add, remove, is a constant time operation. This takes almost O of n time. It's O of n time if both A and B are the same. Yes,
Minimum, the shortest. between A and B.
it's n plus m, technically is what the time would be. We've never had to deal with that before. Don't worry about that. You don't have to deal with that on the exam. Technically, the correct answer is n plus m. It's if n and m. This is why I hate mathematicians sometimes. They n and m. Am I talking about candy? If list A's size is significantly bigger than list B's, or the other way around, then it does make sense to like treat them differently, right? Yes,
Sorry, 2 questions. So like, for the while loop runs in O of n, right?
right.
Second question, instead of saying list data are removed 0, can you just say list data again 0?
Yes, but then we wouldn't remove it, which would mean that this loop would go infinite. We're removing the items from A and B so that it won't go infinite. Yes.
We need all 3 while for the merge function.
Yes.
Merge method, okay.
Yeah, we need or you could do the add all method instead for these two. But people don't like it when my code errors, so. All right. Now, yes.
So like, instead of doing the last 2 while, right? And we always just point the next like pointer of our result.
You could if this was an instance method, but I specifically said this was a static method, so you couldn't access the pointers and the nodes. Make sense? Okay. Because I wanted to challenge you using these things. Yes. Well, pretty sure that O of n is the best way to do it because merge sort runs in O of n and log n time. So, and basically each layer has n items that need to be merged in it in separate merge operations, but overall there's n of them, and then there's log n layers. If you got multiple processors though, then everything goes out the window. So there is, all right, let me move on to this next. I'm going to skip reverse right now because I want to make sure I get to this one. Okay. But reverse is, again, super well known. Look it up on the internet. You will see like a million answers to this one. Okay. It won't be on the exam because that's not what I want to test there. So instead, I'm going to do this one. Let's suppose we have a new type of linked list called a sorted linked list, right? And again, the idea, if you haven't looked at this problem before, is that there is no add at index for a sorted linked list because the idea is that the sorted linked list will keep everything sorted for you automatically. Make sense? Now, for this one, for the sake of ease of writing, we are going to assume that it is that sorted linked lists only deal with integers. However, you can get some extra credit if you remember how to use compare to, right? But if you want to just simply write this out as quickly as possible, go ahead and feel free to use, your integer comparisons and assume it only does integers. I'm going to do here because again, I have 20 minutes left and I want to spend 10 minutes on this and then 10 minutes on the next one. This is also our second question dealing with linked lists that are sorted in some way. This is what we call in the pedagogical business a hint, so. So anyway, this one deals with an actual class that we're going to have to create called sorted linked list. Okay. And then again, this is one of those annoying things that if you want to have, if you need to have, where if we want this to like compile, which you don't need to for the exam, but if you're like me, it's going to bug you if it doesn't compile. So we would have to write like an actual class around it to get it to work. And so sorted linked list, it's going to have, so I'm going to create a private node, private class node. That's just simply going to take in It's gonna have, you know what, I'll do class node E. Yeah. No, int item. And then node next. And then I'll just make the constructor public node int item, because now it will be very easy to switch over to the E if I want to. Node item is equal to, and then this dot item is equal to item. Okay. So I've created that class, and then again, we just need our instance variables here, which will be node head. I'm going to do a node tail as well. See. So singly or doubly, I'm going to assume that we needed head and tail in here. I didn't specify that you needed tail. You most certainly need a head. Don't need a tail, but want to make sure. So anyway, but again, the add method, there's only add an item. It will, and the add method figures out where it needs to go. For instance, we add 5 to this already existing, or if we add 4 to this already existing list, it's going to become 1, 2, 4, 5. It's going to put the 4 in the sorted location. Yes. When I tell you, but sorry, but for this question, you pretty much all the time. This is where I'm saying here we probably want to actually use generics. I'm just saying that you can use less than or equal to. Yes. Yes. If it was that would probably be a fifth of the points. So let's go ahead and do public add, and again int item. That feels so weird, but I can always go back and fix that. Public and void, because we're just changing the list. Doesn't need to do anything. Okay, so we're adding an item to this. So it's a sorted linked list. So let's think about our case.
4 hours though, but
You
like,
turn after 4 hours?
I don't think so, like.
Well, you were driving.
Okay, so when we're dealing with the linked list, basically we have to think about our cases. Okay, like what cases are going to matter. Adding to the head, that, you know, changing the head of the list, that's going to matter. Changing the tail of the list, that's also going to matter, right? And also if it's the only thing in the list, that's probably going to need its own setup, right? We don't have to worry about though the index being out of bounds though, so that's good. So let's think about this, right? If it's the only thing being added, okay, then all we have to do is we have to do if, yep, so I will need a int, yep, an int size to test this. Again, if you don't need any of this stuff around it, okay, for the actual exam. All I care about is the method, but it's still useful to have. Equal to 0. If size equals 0, then this, so yeah, we can always just go ahead and make a node adding. Node adding is equal to node item. Boom. New node item. And then if size is equal to 0, head is equal to adding. Tail is equal to adding. And then that's all we need for that because it's the only item in there. Also, we're gonna definitely want to do size plus plus over here. If you forget that, that's gonna be like a minor thing. Don't worry about it. Okay. It will just prevent you from testing your code. Okay, so there's other conditions. What if we are adding to the head of the list? Now, traditionally, what we would do to tell if we were adding to the head of the list, we'd be asking if the index were 0, right? But we don't have an index here. So if we're dealing with a sorted linked list where the items are sorted, what would be, how would I know I'm adding a new head? What condition would that be? Yes. Yes, if the item is less than everything else in the list, which means that it's less than the first thing in the list. So if item is less than head.item, then adding dot next, then we attach it. Adding dot next is equal to head. Okay, head is equal to adding. So attach our new node and then connect it. And connect our new node to the list at the front, and then make the front of the what's now at the front of the list the new head. That's all we need. Okay. Similarly, what if we're going to the back of the list, right? What if we're attaching to the back? Same thing.
Bigger than the last item,
Yep.
bigger than the tail.
Else if item is less than if is equal to tail.item, I was just on autopilot because talking and coding is really tough. If item is greater than the item at the tail, then we simply say tail.next is equal to adding. We say, hey, there's going to be a new thing that's bigger, and because it's bigger, it's going to become the new tail. This is the only times that head and tail are going to change. So otherwise, we have an else, everything else case. So in this case, what we need to do is that we need to basically iterate through. And what we're going to do is that we know that it's got to be somewhere between the start and the end point, right? So we will, second, annotate. Okay, so if I've got a bunch of nodes over here, right? What I'm going to do is I'm going to create a current. You know, I can't just go to a specific index. What I'm going to have to do is I'm going to have to create a current. And I'm going to ask, hey, is the item I'm adding less than, so let's say current is over here. I'm going to ask, is the item that I'm adding less than this item here, this one over here? And if it is, so if it's less than this item, then what I want to do is I want to take my new node. I'm going to take adding. I'm going to make its next point to here. And I'm going to take the current node that I'm on and make it point to here. Right. I'm going to basically insert it in between. Okay. When you're working through this, generally the last condition you want to deal with is kind of the stopping point, figuring out what the stopping point is, but that's because that can be sometimes hard. But here we know it's going to be in between. So what we have to simply say is, well, we're going to simply create we're going to do node current is equal to head, while current is not equal to the tail. In other words, while we haven't gotten to, well, what I'm pointing at is not the last item. We don't want to get to the last item because we know that our item is bigger. It's going to be smaller than the tail. Okay, we know that the tail is going to be bigger. So while the current is not equal to tail, we're going to remember that we're going to do current is equal to current.next. Okay. And what we're going to do here is we're going to say, hey, if current, so if, so this is going to look a bit weird, but what we're doing is that we're trying to is that if this is current, then what we want to check is we want to check this item over here. Mm-hmm.
Why did you say current ahead if you're in check that case?
You're going to see, because we're going to start at head. We're never going to check head. What we're going to check is head.next to ask if we have to. So what we're going to do is that we ask if current dot next dot item. We're going to do if the item I'm trying to add is less than current dot next dot item. So if, in other words, I'm at current, I know I'm bigger than that item. And let's go ahead and just deal with equal to cases in case, right? I know I'm bigger than this. I know that I'm bigger than the item I'm currently on. So what I'm doing is I'm asking, hey, is the item after me? Should I go before it? Because I'm either because I'm either smaller than that or equal to that. If I'm smaller than the next item, that means I need to go in front of it. Make sense? If I'm smaller than the next node's item, that's where I need to go. So what I would do in that case is say, hey, adding dot next is equal to current dot next, right? So current in this case is actually acting like the before in the other cases that we would have. Okay. So adding dot next is equal to current dot next. And then current dot next is equal to adding. And that's how we just simply stitch it in right there. Now we're done with this loop. We don't have to continue going on because otherwise it could get awkward if you know there were repeats. So I'll just stop the loop by calling a break. Okay. Again, I will upload this all to Discord for you to use. You know, and I will try to, let's see. Yeah. So now let me go on to the last question, which is going to be this question, which I told you will be on the exam. Okay. So this isn't going to be me like lecturing, or sorry, writing anything down. I'll just be talking for a bit. Okay. So lists, and so we've got two types of lists. We've got lists and array lists. Sorry, linked lists and array lists. Whatever one is good at, the other is poor at. Although in terms of their operations. So add and remove and get and set. They also differ in how they use up memory. So that's where we'll start. How do they use up memory? Array lists are fairly memory efficient in the sense that they do have like this, they allocate this big block of memory for you to use, and then you fill it up. If you need more, you reallocate, meaning you grab twice as much space. And it's basic. So you just use basically as much memory as you need for it. That being said, there is a place where it does break down, which is that if you're adding, if the capacity of this is 100, okay, if the capacity of this is 100, and you try to add your 101st item, right? We're going to then reallocate, and we're going to transfer everything over to this, right? To this one that's twice the size. And then you're going to insert your 101st item, right? But if that item, that's the 101st, is your last item, then you're leaving all this wasted space on the table. So array lists can waste space by having unused space. Make sense? Now there are usually methods built in to programming languages to allow you to snip that or reallocate the other way to make sure that basically you shrink the used the used space down to where we are, to shrink the capacity to the size. There we go. But a lot of times we don't see that because but you're never gonna have a built-in reallocate method whenever you remove something, because then you could get into a nasty cycle of adding and then having to reallocate and then removing and then having to reallocate, and it just gets very awful. So in other words, so long story short, array lists can waste space by wasting unused space. On the other hand, nodes, so linked lists waste in a different way. They have linked lists, they don't waste space, but what they do have is a lot of overhead. For every item, okay, we have a node, and the node holds three things. It has the memory location of the node, which by the way, so does a linked list. Sorry, an array list. The array list is just basically holding the memory location of the item. Okay. Then also, linked list will also have a next and previous pointer. So in other words, linked lists use 3 times the amount of overhead as an array list does. So it's more in overhead. So a linked list memory wise will be less memory, should be less memory efficient than a fully utilized and trimmed array list, right? But then again, you're not going to be, wasting by any, you're not going to have any wasted space. It's actually all going to be used for something, right? Whereas with an array list, you're possibly going to waste space. Yes. In production, I believe they do. In production linked lists, yes, I believe they do. Yep. In a circular, so like your most linked lists are doubly linked. When we do singly linked, it's basically because there's less writing involved and less potential places for error. So that's memory. There's two other ways we look at these things, which is the add remove operations and the get set operations. All right, let's go ahead and look at the get set operations first because those are easier, right? Less complicated. Get and set are fairly straightforward. They're reflexive. For a linked list, sorry, for an array list first. For an array list, getting and setting. Get and set are both constant time operations because you just simply go to the index in question, right? You go to the index in question, it's just doing a mathematical operation to get to that memory location because it's using an array. It's a constant time lookup. On the other hand, a linked list, the get and set takes O of n time to get there. Takes O of n time to get there, okay? And why is that? Because you have to search for the node. It takes O of n time to find the index you're going to, right? Make sense? Now, obviously, if it's the header tail, that's constant time, but honestly, that's for get and set, we can just keep it simple, right? Because where we care about the exceptions is here when we talk about array lists versus linked lists for add and remove, because this is where our exceptions come up. They come up, we have a lot of exceptions in this case. For a linked list, adding in a linked list is constant time for head and tail, which is, by the way, where you do the majority of your adds, either to the beginning or at the end of the list, right? You're very rarely adding to a random pointed list. Adding to the header tail, it's constant time for the header tail. Otherwise, it is constant time plus the seek time, right? In other words, constant time plus get node, which is, otherwise O of n. And you're probably going to want to put more detail than what I'm writing down, right? Use more words than I'm writing down, and instead, instead focus on what the words coming out of my mouth are. All right, so, but in summary, linked lists, constant time for adding to the header tail. Otherwise, you have to look for where you're going, so it's O of n. Array list, yes. You have to literally iterate one node to another, to another, to another to get to the index you want to find. Right? It's the scavenger hunt, right? Whereas an array list, to get to a specific index, you just have to use you just do a very quick math calculation to say, oh, here's the memory location of the beginning array. Here's the offset. Here's the index I want. So here's how big the slots are of each item in the array is. So I'm just going to do a quick memory calculation to figure where that is in memory. It's basically just doing a addition and multiplication operation, I think. Yes. So for array list, though, to add, it is generally O of n, add anywhere to or remove anything from an array list, except when. Yep, except. Except when? When wouldn't adding to the end be constant time? Yep. So basically, there's two kind of things that could go wrong that would go wrong with adding an array list, right? That change the runtime, whether you're adding to the end or you're reallocating. If it's reallocating, it's going to be O of n no matter what. But if you're not reallocating, if you're adding to the end, it's going to be constant time. If you're adding somewhere else though, right, it's going to be O of n time because you have to physically shift all the items over, right? That is why it takes O of n time for everything. When you're working with an array list, you have to shift everything over to make room or to adjust for having removed something. Okay. This in general is what takes the time. When you're operating on the end, there is no shifting. Okay. So that is everything for that. I will send out additional instructions as well as this. I will send this out because we're at time before I'm wrapping up here, but I went through everything but the reverse function. Again, if you're interested in finding out how the reverse function works, one of the most well-known linked list questions out there is reversing a linked list. What? It's the same. It's the same as add, essentially. It's the same as add, except you don't have to worry about reallocating when you're removing. Yes. What? So, I care about pairs. I care about memory, add, remove, get set. Three things, because it's memory and two pairs of methods that basically go together.
So if you have to reallocate while adding, how does that change?
You have, that's O of n, because what you have to do is that when you have to reallocate, you have to create something that's twice the size, and then you have to move n items over into that. And then you finally get your.
As if you were just adding to the middle.
Technically,
If you're adding to the middle and you have to reallocate.
then you, yep. Because again, it comes down, all these things are basically like O of n over 2, n over 2, or 2n plus 1. But in the end, the beauty of basically using big O notation is that you can just simply simplify it to O of n.
Well, I was thinking it might be rare because after it goes through everything. Like, what if it goes through everything and it realizes it's too big for that space as soon as you add it?
It's not
Or
going to be
after you shift everything.
it's not going to be the only times it would be O of n squared the only time squares come into the into this is when you do repeated operations.
Like double loops.
When you do doubly nested loops.
Question, so like on the exam, say like it's last case scenario, we don't know.